Welcome to Black Hole Basics, where we explore the darkest corners of the cosmos and the mysteries that lie deep within. Have you ever wondered where the Earth ends and the rest of the vast, infinite universe truly begins to start? We often hear the term deep space in movies and news, but it is actually a very specific scientific definition. To understand deep space, we must first identify the boundary where our home planet's atmosphere fades into the cosmic void. Most of our human activity, including aviation and weather balloons, happens well within the protective blanket of our dense atmosphere. Even the International Space Station, orbiting just above us, is not considered to be in deep space by most definitions. So, does deep space begin at the moon, or do we need to travel much further to earn that title? According to NASA and their communication networks, deep space begins at a specific distance slightly beyond the Earth and Moon. Technically, anything beyond the distance of 2 million kilometers from Earth is officially categorized as deep space exploration territory. This means that while the Moon is our neighbor, traveling past it enters a realm of true isolation and silence. Why do we call it deep? The term implies a vast vertical drop, a profound distance from the surface of safety. Just like the deep ocean, deep space is an environment where human survival is impossible without advanced technology and protection. As we venture further, we encounter the interplanetary medium, a space dominated by the solar, wind, and magnetic fields. Deep space is not empty. It is filled with plasma, cosmic rays, and dust that travel at incredible speeds. To communicate across these distances, we built the Deep Space Network, a collection of massive antennas spanning the globe. These antennas are our ears and mouth, allowing us to whisper to robots that are billions of miles away. Consider the Voyager probes, humanity's most distant emissaries, currently traveling through the ultimate definition of deep space right now. They have crossed the heliopause, the boundary where the sun's influence wanes and interstellar space officially begins to take over. Inside this bubble, we are protected. Outside, in deep interstellar space, the environment becomes even more harsh and unpredictable. The distance between stars is so vast that the human mind struggles to comprehend the sheer scale of nothingness. In deep space, communication is not instant. Light takes hours or even years to travel from there to here. This time delay creates a terrifying reality where a spacecraft must survive on its own before we know its fate. When landing on Mars, the delay is so long that the rover is already down before we receive the signal. Jupiter is 5 times further from the Sun than Earth, plunging it into a colder and darker region of space. Out here, solar panels become less effective, forcing spacecraft to rely on nuclear power sources to keep their systems running. At Pluto, the Sun is merely a very bright star in the sky, providing little heat to this frozen world. Beyond Pluto lies the Kuiper Belt, a debris field of ice and rock left over from the solar system's formation. This is the home of comets, ancient travelers that spend millennia in deep space before visiting our warm inner sanctum. Further still is the Oort cloud, a theoretical shell that marks the gravitational limit of our Sun's deep space influence. The Oort cloud extends nearly a light year away, a distance that challenges our understanding of scale and gravitational reach. To travel beyond this, into the deep space between stars, we would need propulsion technologies that do not yet exist. The nearest star system, Alpha Centauri, is over 4 light years away, a journey that would take us thousands of years. Astronomers use telescopes like Hubble to peer into what is known as the deep field, a tiny patch of sky. In that tiny, dark patch, they found thousands of galaxies, proving that deep space is teeming with ancient light. Now, the James Webb Space Telescope looks even deeper, capturing infrared light that has traveled for over 13 billion years. This allows us to see through dust clouds and witness the birth of stars in the deepest regions of space. Deep space is also defined by the expansion of the universe, stretching the light from distant objects into red wavelengths. This phenomenon, called redshift, is how we measure the extreme depth and distance of objects at the universe's edge. In these deep regions, we find monsters like supermassive black holes, anchoring the centers of galaxies with their gravity. These cosmic giants release energy that can be detected across the entire visible universe, acting as deep space lighthouses. There are also voids, like the Boat's void, vast areas of deep space that contain almost no galaxies at all. If you were in the center of such a void, you would see nothing but absolute darkness in every direction. The deepest image we have is the cosmic microwave background, the afterglow of the Big Bang itself. Looking into deep space is effectively looking back in time, seeing the universe as it was billions of years ago. This connection between space and time is why the term deep is so appropriate. It is a temporal depth. For humans to explore deep space, we must conquer time, perhaps through hibernation or generation ships that sustain life. A generation ship would be a moving world, where children are born and elders die while traversing the deep void. But deep space is hostile. Cosmic radiation poses a severe threat to human DNA and biological systems over long durations. Engineers are developing new materials and magnetic shields to create artificial magnetospheres for deep space vessels. The psychological impact of deep space, known as the break-off effect, is another major hurdle for future explorers. When Earth becomes just a star in the sky, the feeling of detachment from humanity will be profound and permanent. Robots like New Horizons do not need air, food, or psychological comfort to survive the cold darkness of the Kuiper Belt. Robots like New Horizons do not need air, food, or psychological comfort to survive the cold darkness of the Kuiper Belt. They patiently gather data and send it back, acting as our remote senses in environments that would kill us instantly. Navigation in deep space requires extreme precision, relying on atomic clocks to measure time and position among the stars. Future ships might use pulsars, the spinning lighthouses of the galaxy, to triangulate their position without help from Earth. We must also remember that deep space is silent. Sound requires a medium like air to travel, which is absent. However, space itself can ripple. Gravitational waves stretch and squeeze the fabric of reality, carrying secrets from deep events. These waves allow us to hear the collisions of black holes that happened billions of years ago in deep space. Deep space is also filled with mystery. Dark matter makes up most of the mass, but remains completely invisible to us. Dark energy is an even greater puzzle, a force that is pushing deep space apart faster than gravity can pull. Understanding these components is crucial because they define the structure and ultimate fate of deep space itself. Our own galaxy is 100,000 light-years across, a scale that makes our solar system look like a single atom. Andromeda, our nearest galactic neighbor, is 2.5 million light-years away, a truly deep chasm of intergalactic space. Eventually, these two islands of stars will merge, reshaping the deep space environment of our local group forever. We listen to deep space not just for science, but for signs of life. Are we truly alone in this? The search for extraterrestrial intelligence, or SETI, scans deep space for radio beacons from other advanced civilizations. We have discovered thousands of exoplanets, some of which might host oceans and conditions suitable for life to exist. By analyzing the light passing through their atmospheres, we look for biosignatures, chemical fingerprints of life, in deep space. But finding life is difficult because deep space is a haystack of billions of stars, and we are searching blindly. The Fermi paradox asks, if deep space is so vast and old, why haven't we heard from anyone yet? Perhaps civilizations rise and fall too quickly to communicate across the vast, time-consuming gulfs of deep interstellar space. Light pollution on Earth hides deep space from our eyes, disconnecting us from the universe that gave us birth. In dark sky reserves, we can still witness the true depth of the cosmos with our own naked eyes. The future of deep space exploration begins with the Lunar Gateway, a station that will orbit the moon soon. Private companies and national agencies are building the heavy rockets needed to carry humans into deep space safely. Mars is the first step, But the dream of deep space pushes us towards the moons of Jupiter and Saturn. Europa may hide a subsurface ocean twice the volume of Earth's, a prime target for deep space astrobiology. Sending a probe to melt through the ice and swim in that alien sea is a future deep space goal. Titan offers another strange world, the only moon with a thick atmosphere, raining hydrocarbons onto a frozen landscape. NASA's Dragonfly mission will fly through Titan's sky, marking a new era of drone exploration in deep space. Deep space also holds resources. Asteroids contain rare metals and water that could fuel a spacefaring economy. Harvesting water for fuel in space will allow us to travel deeper without lifting everything from Earth's gravity well. Visionary concepts like space elevators could eventually make deep space accessible to more than just professional astronauts. Imagine a future where a trip to the moon is as common as a flight across the Atlantic Ocean. But we must be careful. Space debris threatens to trap us on Earth, blocking our access to deep space. If we pollute our orbit too much, the Kessler syndrome could destroy our satellites and end the space age. Governing deep space requires international cooperation. Who owns an asteroid? Who makes the laws on Mars? As we go deeper, national borders vanish. In deep space, we are simply representatives of the human species. New propulsion methods like solar sails use the pressure of light itself to navigate the currents of deep space. Engines, which shoot out charged particles, are slow but incredibly efficient for long-duration deep space missions. Nuclear thermal propulsion could cut travel time to Mars in half, reducing the radiation exposure for the crew. Theoretical physics suggests wormholes might act as shortcuts, folding deep space to allow instant travel between stars. While warp drive remains science fiction, scientists are seriously studying the math behind bending space and time. Future telescopes will be even larger, capable of resolving the surfaces of exoplanet in deep space directly. Imagine seeing the continents of another world, confirming once and for all that Earth is not unique. Deep space tells us the story of our universe's life, from its fiery birth to its eventual cold death. In the far future, deep space will be a graveyard of dead stars, a concept known as the Big Freeze. But life is resilient. Intelligent beings may find ways to survive in deep space long after the stars fade. Bringing our focus back to the present, deep space reminds us of the fragility and beauty of our home. We are creatures of the surface, looking out into the deep, driven by an ancient curiosity to explore. The next generation of explorers is watching this video, dreaming of the day they will travel to deep space. We have come so far in just a few decades, from the first flight to walking on the moon. Deep space is not a limit. It is a canvas waiting for us to paint our future upon it. If you could travel anywhere in deep space instantly, where would you go? A nebula? A black hole? The definition of deep space will change as we travel further. One day, Mars might be considered near space. Until then, we rely on the Deep Space Network and our robotic avatars to bridge the gap between worlds. So, deep space is defined by distance, communication delay, and the profound isolation from the safety of Earth. It is the frontier where science meets philosophy, challenging us to understand our place in the grand cosmic design. Thank you for joining us on this journey into the dark, cold, and fascinating depths of our universe. If you enjoyed this deep dive, please hit the like button and subscribe for more cosmic content every week. This has been Black Hole Basics. Keep looking up, and never stop wondering what lies out there in the deep.